the theorem of Pythagoras, your knowledge of reduction formulae. Okay? So the first question says, show that angle D is equal to 180 degrees minus 2 alpha. So your angle D is this one here. That's angle D. Now, any question which involves angles like this is not, it's all about trigonometry, and sometimes there's a combination of trigonometry and geometry. But it actually appears to be geometry. In this case, it's geometry of triangles. Okay? So BD is equal to CD, which means that will also be X. Okay? And C2, okay, C2 is opposite X, and angle alpha is opposite X. Okay? So if you want to find this, that is A1. So we say in triangle, remember what I told you last time, the moment you have got triangles, you need to identify the triangle and name the triangle correctly. Okay, so our triangle that I'm going to use here is triangle BCD. So in triangle BCD, okay, well, this is very straightforward. If this is alpha, okay, it's opposite X, and that's also X equals alpha. My suggestion here is to first write and say C2 is going to be equal to B2, and they are both equal to alpha. And the reason that you might you have to give here is to say, now remember these are angles, okay? So the reason here could be angles opposite alpha. You have to write that by that way. So C2 is equal to B2, they are both equal to alpha. The reason, because they are angles opposite what? Equal sides. Okay? What this means is, if I want to calculate angle D, it's going to be 180 degrees minus alpha. And my reason here will be sum of angles in a triangle. So this will give us 180 degrees minus 2 alpha. Like that. Okay, so it's very straightforward. But I need to warn you, don't just write an answer for a question like this. You need to provide some working out and so on. So it requires knowledge of geometry, then you must do so. Okay, then the second question now. You are supposed to prove that y is equal to x sine 2 alpha divided by sine alpha cos beta. Okay? Now, if you look at it, triangle BCD is not a right angle triangle. Usually, since we have got a right angle triangle ABC, it means we need to connect that triangle with triangle BCD, such that we know the length of BC in terms of triangle ABC, also in terms of triangle BC. So that requires a bit of some thinking. But it's not complicated. Let me adjust this. Okay, this page is supposed to be there. Right. Okay. So, first, I'm going to write an equation in terms of y, because of this y. Then I'm going to connect, so I'm going to use triangle ABC first. Let me multiply this as well. So I'll say in triangle ABC, okay, if I want to calculate, remember, these two triangles ABC and BCD, they have a common side, isn't it? Right? Which is what? BC. So I have to use that side. Okay? I need an equation which includes BC from triangle ABC. I also need another equation which also involves BC, okay, a little bit from triangle BCD. Then I'll equate now the values of BC for both equations. And then I'll be done. So I need two equations here. And those two equations, I can obtain them from the two triangles. So the first equation, I'll use triangle ABC. Remember, this is our reference angle. Obviously, y is our hypotenuse. Therefore, AC is going to be the opposite side and BC will be the adjacent side. Okay? So, to get this cos beta here, it comes from using triangle ABC. Okay? So, this will be cosine of beta is going to be equal to BC over y. Okay? What this means is that BC is going to be equal. Okay, well, let me make y the subject. It's very interesting. So, y will be equal to BC over cosine of beta. Alright? Now, I need to eliminate that numerator. Because if you look at my expression here, I don't have BC. So the only way that I can eliminate the numerator is by using triangle BCD. Okay? So I've got my BC is opposite this angle, which I found. Okay, actually it's given 180 minus 2 alpha. Then I know that this is x, that's also x. Well, here you'll be spoiled for choice because the triangle BCD is an isosceles triangle. So I think for today, I'll just use B2 and that's CD, okay, in terms of my sine rule. So with regard to my sine rule, I'm going to write BC divided by sine D will be equal to, in this case, it will be equal to x over sine B2. Okay? Then BC will be equal to x sine 180 degrees minus 2 alpha. This is all over sine B2. Are you following that? It's a proof, by the way. Okay? Now your reductions now come in. Because you are in term 3, you did reduction formula in term 2. Sine 180 minus 2 alpha is the same as sine 2 alpha. Okay? So this will become BC is equal to x sine 2 alpha over. Now B2 is equal to alpha, so that will be sine alpha. Now I'm smiling. All I have to do is just take the right hand side here and put it where there is BC in the first equation. Okay? So if I call this one here my equation 1, okay, this here will be equation 2. Okay? Let's substitute. So let me go to the next page. So I'm going to substitute this where there is BC in the first equation. Already I'm smiling because things are on track. So this will be y equal to BC. It's going to be x sine 2 alpha over sine alpha. X sine 2 alpha over sine alpha. Okay? Now, because BC is dividing cos B here, it would be better to introduce the division line to make things easier. So I'll put cos beta there. Instead of dividing x sine 2 alpha over sine alpha, I suggest that you do it that way. So that the next step becomes x sine 2 alpha over sine alpha times 1 over cosine of theta. And this will give you x sine 2 alpha all over. Well, you can look at how it's written. Start with sine alpha first. So that will be so this will be sine alpha cosine of theta. So that's what. Right. So that's what you should have done. It's very easy. Yes. Okay. So a question like this, it will be the last question on trigonometry. Usually it comes after graphs. Okay, after your trigonometric graphs, then the next question will be on 2D or 3D problems. But this is a 2D problem, by the way. Okay? Then the last question now is very easy. Just require you to substitute. So let's substitute. So the last question says, if x is equal to 150 meters, alpha is 30 degrees, beta is 70, calculate y. Now this is very simple. So y will be equal to, x is 150 meters, right? And then alpha is 30, so this will be times sine 2 times 30 degrees. This is all over sine 30, which is the half, times cosine of 70 degrees. What answer do you get? Huh?
Sir, can you please put in the calculator yourself?
Why are you scared?
Because the answer.
Okay, so it's 150. First, you start by putting your fraction option. That's the first thing. Then 150 times sine. Now, that will be sine 60 degrees. Okay? That will be sine 60 degrees. Yes. 2 alpha means 2 times alpha. So, what is alpha? 30 degrees. 2 times 30, 60 degrees. Okay? You have to be aware of that. It's not that difficult. Then sine 30 times cos 70. Then we get our nice answer.
That's what I was scared of.
Yeah, it makes sense.
But then
Yeah, because you see, remember, we are given x as 150. So we're supposed to determine the y. Obviously, by observation, y should be greater than what? X.
no, but it looks wrong.
Okay, the diagram is not drawn to scale. Okay, the diagram, so it will be 759,63. 759,63. So it will be 759,63 meters. Yeah. Is it meters or units? But if they put meters here, so it's in meters because it's 150 meters. Okay. All right. Any questions? Any question? All right. The next question. Right. The next question is also on it's a 2D problem. So you've got two observers standing at D. Right? Now this question requires your knowledge of angles of elevation and depression. Okay? So two observers standing at D are looking up at an office. So it's like they are looking, like me standing in front of you, I'm looking at those lights. Okay? So I've got my horizontal plane, okay? Then my line of sight. The angle between the horizontal plane and my line of sight, that's the angle of elevation. Okay, one observer is looking up at a name placed on the building at B. Okay, one is looking at B here, the other at the top of the building. Okay, angle of elevation of B from D is beta. Then the angle of elevation of A from D is alpha. They are both y meters from the building. Right, when you're answering this question, you also have to use common sense. Okay, common sense. So the question says, show that the distance from the nameplate to the top of the building is that. So that's the distance. Which distance are we talking about? Well, one observer is looking at a nameplate, which is at B, which is this one here. Right, and the other at the top of the building, which is there. Right? So we need to show that the distance from the nameplate to the top of the building is that. Which means we're going to calculate AB, isn't it? Huh? So we're going to calculate this distance. Okay? Well, I'm sure you can agree with me. How many right angles do we have here?
One.
Right angle triangles. There are two.
Where?
There is ACD, there is also BCD.
Oh, okay.
Okay? Now, I'm also sure that you can agree with me that if I'm going to calculate the length of AB, I can get the length of AC, get the length of BC, then do a what? A subtraction. Isn't it? Okay? I think that's the route which I'm going to take. Okay? That's the route which I'm going to take. But that's not the only way to. Okay? If I want to calculate AB, right, based on the information that's here, obviously there must be a right angle there. Because this is a building, so it must be perpendicular to the horizontal plane. Right? So I can determine the size of this angle here. You see this angle here? It will be equal to alpha minus what? Beta. Isn't it? Okay? Why would I need that? Because I'm looking at my expression which I'm supposed to show. Okay? And I'm realizing that I think I might need to use triangle ABD to show that. Because it's only through triangle ABD that I can determine that alpha minus beta. So when you're doing a question like this, don't be scared. Look at what you're supposed to show. Let it guide you to the answer. Ask yourself, how can I create this alpha minus beta? The only way you can create the alpha minus beta is by subtracting beta from alpha and to get this angle, that is angle ADB. That's the only way. Okay? Which means trying to calculate the length of AC and then getting BC and subtracting and so on, you might not be able to get the answer because of this alpha minus beta. Okay? So you have to think there. So this angle is equal to alpha minus beta. Okay? You're following there. Then if I wanna, so I now have a side, isn't it? Which is AD, which I wanna determine, and then the angle which is opposite it. So the next thing is for me to try and find another angle in the side. Yes?
I think he accidentally wrote angle of alpha minus alpha. Okay.
So maybe it would be better, okay, it would be better for me to calculate BD. Okay, I'm going to calculate BD. Then after calculating BD, I'm going to need to know the size of this angle. Okay? Do you agree with me that the size of angle A is going to be equal to 90 minus alpha, isn't it? 90 minus alpha. This whole angle here is equal to alpha.
Wait.
The bigger angle is alpha. The smaller one is what? Beta. So this angle here is going to be 90 degrees minus alpha. Okay? I'm almost there now. And I'm thinking now about my reduction formula. Because if I say sine 90 minus alpha here, I'll get cos alpha. If I say cos 90 minus alpha, I'll get what? Sine alpha. Which means this cos alpha here is likely to come from sine 90 minus what? Alpha. Okay, let's get on. So let's calculate BD. So I'm going to use triangle BCD to calculate the length of BD in terms of y. Okay? So here I'll say in triangle BCD. Okay? Now BD is my hypotenuse. I have got my angle here beta, which means this side is the opposite, that's the adjacent. So the adjacent side is given. The hypotenuse is not given, that's the one I want to calculate. My reference angle is beta. So this will be cosine of beta will be equal to the adjacent side y over BD. Okay? So what this means is that BD is going to be y over cosine of beta. Are you following there? I'm almost there now. I can see smiling a little bit. So I'm going to use the sine rule in triangle ABD because I now know BD in terms of y. Hello, hello. You're following there. Okay. So let's go to the next page. So I'll say in triangle, it will be triangle ABD. I'm going to use the sine rule. If I use the sine rule, I'm going to say AB over sine alpha minus beta. Okay? AB over sine alpha minus beta. AB over sine alpha minus beta. But I'm writing alpha again there. Okay, let me delete that. Okay, my pen. Okay, so that should be sine alpha. Maybe today I like alpha a lot. Okay, then, so it's AB over sine alpha minus beta. Since I know BD, it will be BD over sine 90 minus alpha. So it will be BD over sine 90 degrees minus alpha. Okay, all right. So allow me to just simplify this. So AB is going to be equal to BD sine alpha minus beta over. Now, sine 90 minus alpha is the same as cos alpha from your reduction formula. Okay? Are you following that? But I don't need this BD here. But the good thing is, from the previous page, I've got a formula for BD. I've made BD the subject. So all I have to do is substitute y over cos beta. Okay? So if I substitute y over cos beta, this is going to become y over cosine of beta times sine alpha minus beta all over cos alpha. Okay? Which means I can now safely say that AB will be equal to y sine alpha minus beta divided by cos, well, let's start with cos alpha. So that will be cos alpha times cosine of beta. Okay, and then we are done. So method 2, this will be method 2 now. So let's talk about method 2. So this was method 1, by the way. So method 2 is going to involve, using, okay, in triangle ABD, you can determine the size of B1. I'm sure you can agree with me that B1 is an exterior angle of triangle BCD. So B1 is equal to angle C plus beta. Okay? B1 is equal to what? Is equal to angle C plus beta. Okay? So we can do that. Now, if we know the size of angle B1, means we need to know what is AD equal to. So we can use triangle ACD to determine the size of AD. So let's find AD in terms of y. Okay, so it will become cos alpha is equal to y divided by AD. Okay, that's to emphasize what we're doing. I want to determine the length of AD in terms of y. So I have to use triangle ACD. Okay, I think let me specify the triangle just to make sure that everything is more clear. So in triangle AC, okay, this will be, okay, whereby our adjacent side, our adjacent side, our angle cos alpha, because the adjacent side is 180. You following that? Huh? Right? Since I say B1 is an exterior angle of triangle BCD, so I can also say B1 is equal to 90 degrees plus what? Plus beta. Now this comes from exterior angle of the triangle. Okay? Hence, I can write the sine rule, okay, using triangle, it's a triangle by the way, the triangle ABD. The only thing is that instead of using angle A, I'm using angle what? B1. Okay? So, end up saying in triangle ABD, it will be, okay, in my case I prefer to have the length on top. So it's going to be AD over sine B1. It's going to be equal to AB over sine alpha minus beta. What are we trying to calculate? It's AB. So I can say AB will be equal to AD sine alpha minus beta all over sine alpha. B1 is going to be equal to 90 plus beta. If I carry on here, if I carry on there, okay, it affects my ego. Okay, so this means where there is AD, I can substitute. Okay, so our AD here is equal to Y over cos alpha. Therefore, AB will be equal to Y over cos alpha times sine alpha minus beta over sine 90. Now, sine 90 plus beta is the same as cos beta. Okay? Sine 90 plus beta is the same as cos beta. So we'll come to the same answer. So it will be y sine alpha minus beta all over cos alpha times cos beta. So that will be method 2. Okay. All right. Okay. Thank you very much for that contribution. Okay.